Last time we talked about quadratic functions and their transformations. Today we're talking about square root functions and their transformations. Square roots is another parent function that we have in our journal, and we are going to fill in a table and we're going to graph the parent function. This table and the parent function is in your journal, but we're going to do it on this paper just so we've got it. We're just going to do that one time. So we're going to graph if the x is 0, 1, 4, and 9. We're just going to do those 4. And so if you would take your calculator, turn it on, make sure you're at the home screen, go to a new document. No, you do not want to save it. And we're going to add a graph. And we are going to put in the square root of x. The square root is the yellow key, the yellow square root sign above the x squared. So we're going to do control x squared, and that will give us the square root of x. We're going to hit enter, and there's your graph. Do you remember that parent function? Hopefully that looks familiar to you. We're going to go to control T so we can fill in our table. And our table looks like it's 0, 0, 0, 1, 1, 4, 2, and 9, 3. And do you see why I picked these numbers 0, 1, 4, and 9? Because the other ones gave me decimals. I don't want those. I want whole numbers. They're nice and easy to graph. So once you have that, let's get rid of our table. Your graph is going to look like this when you graph it. So let's do that. We're going to graph 0, 0, 1, 1, 4, 2, and 9, 3. And our graph should look like this. And that is what your graph should look like. So if you're not finished graphing that yet, take a minute, finish graphing that. And we will go and find our domain now. So your domain, remember, is along your x-axis. Well, how far left does this go? This time, this graph does not go to negative infinity. It goes to 0. And it does touch 0, so it is a bracket on 0, and it does go to positive infinity. This range, up and down, does not go all the way down to negative infinity. It goes to 0, touches 0, and it goes up. Notice it's going to the right, but it's also going up, so it's going to go up forever to infinity. So both your domain and range are the same on this parent function. That's not necessarily going to be true on every square root function, so you've got to check it from your graph. All right, let's go on. Graph each of the following square root functions on the calculator. Explain how it's different from the parent function. So what I want you to do is I want you to graph the negative square root of x. I'm not even going to have you do a table. I just want you to graph it. So take a minute and graph that. Okay, I hope your graph looks like mine does. It looks exactly like the parent function, only it's underneath the x-axis. So we're going to say that this one has been reflected across the x-axis. Hey, there's a negative in front. That's exactly what happened with our quadratic function. When we put a negative in front, it reflected across the x-axis. Very interesting. It does exactly the same thing. All right, let's look at the next one. H of x equals the square root of x plus 5. Take a minute, put that in your calculator and graph it, and then we'll graph it on this paper. This graph looks like this. It looks exactly like the parent function, only it looks like it's been shifted to the left 1, 2, 3, 4, 5. The parent function begins at 0, 0. This one is going to begin at negative 5, 0. So it looks like it shifts left 5 units. And that is my change. Now, remember on the quadratic, when you had something in parentheses, it moved left and right, and it always did opposite what you'd think. Well, the square root sign is just like parentheses. So when we have inside the square root sign with the x, we have a plus 5. That means we're going to go left and right, and it's going to do opposite what you'd think, which would be left 5 instead of right 5. Okay, let's go to the next one. F of x equals the square root of x minus 1, and the minus 1 is in the square root sign with the x. So let's graph that one on your calculator and then graph it on your paper. And here is my graph. It looks just like the parent function, only instead of starting at 0, 0, it starts at 1, 0, so it moved to the right 1 unit. And if you notice, that -1 is inside the square root sign with the x. It's just like a parentheses, so it's going to move left, right, and it's going to do opposite what you'd think. Minus makes me think it's going to go to the left, but since it's inside, it's going to go to the right. It's going to do opposite. All right, let's look at number 5. h of x equals the square root of x minus 8. Notice the minus 8 is outside the square root sign this time. So I want you to put that in your calculator and graph it, and then put it on your paper. And here is what I have. I hope that's what you have as well. It looks just like the parent function, except for instead of starting at 0, 0, it starts at 0, negative 8. So it moved down 8 units. Down 8 units. Hey, that's just kind of like what we did with quadratics when we had something outside, excuse me, outside or next to the x squared. It wasn't in parentheses with the x squared, and it just said -8 or -2. It went down that many units. Notice the -8 is not inside the square root, so it's like it's not inside parentheses. So it's just down 8 units. Okay. All right, let's go to the next page. The next one, f of x equals the square root of x plus 3. Notice the plus 3 is not inside the parentheses. Graph that on your calculator and put it on your paper. And hopefully you have the same thing that I have. I have the parent function, except for instead of starting at 0, 0, it starts at 0, 3, so it moved up 3 units. Just like with quadratics. That plus 3 is not inside the square root sign, so it's like it's not inside parentheses, so you just move up 3 units. I'm doing exactly the same thing. Let's go back to the parent function and let's look for a pattern, because I think there's a pattern on the square root function just like there was on the quadratic, so you can figure out where all your points go. So if we look at the very first one, we had a point here, 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 and here. And let's look for a pattern. I'm going to go up 1 over 1, up 1 over 3, up 1 over 5. That's the pattern for the parent function for square roots. Let's look at this one. This one was reflected across the x-axis, so it's going underneath the x-axis. So we're going to go down instead of up. So I'm going to go down 1 over 1, down 1 over 3, down 1 over 5. This one looks just like quadratic, except for instead of going up 1 over 1, up 3 over 1, you go down 1 over 1, down 1 over 3, down 1 over 5. So it's kind of like this, the half of the quadratic sitting on its side is what it looks like. Let's look at number 3. We have up 1 over 1, up 1 over 3, up 1 over 5. Same pattern. Let's look at number 4. Up 1 over 1, up 1 over 3, up 1 over 5. Same exact pattern every time. Number 5. Up 1 over 1, up 1 over 3, up 1 over 5. Same pattern. Pretty cool how it works out that way. And then this one was up 1 over 1, up 1 over 3, up 1 over 5. Same pattern. Now this one is going to have a 2 in front, so I want you to graph that one in your calculator and then graph it on your paper, and we'll see what we get. Here's what I got for this one. This one looks like the parent function, only it's kind of stretched vertically again because it's taller. And so what this pattern does is it goes up 2 over 1, up 2 over 3, up 2 over 5. Notice the over 1 over 3 over 5 doesn't change. It's the up that changes. So since there's a 2 in front, we're going to double how many we go up. On all the other square root functions, we just went up 1 every time, so we're going to go up 2 every time. This one's a little bit easier to graph than the quadratic. So this is a vertical stretch by a factor of 2. It's exactly like the quadratic. In fact, all of these do exactly the same as the quadratic. So I want you to go ahead and fill in these on your paper. I'm going to give you just a couple of minutes to fill those in and see if you can figure out what the change is.